All right, here we go. Today we are going to finish up lesson 2. So we are going to finish up evidence C, evidence D, and then you are going to begin your SmartBook questions through McGraw-Hill Red Square. And if you have time today, you will then complete 2 learn checks. The first learn check that I would do is the one from last week. It's a redo because some people forgot to do it, whatever, so you guys get a second chance on it. The second learn check is going to be over the content from our lesson this week. So it sounds like a lot, and it is a lot, but I need you guys to put your headphones on, stay in your seats, and get this work done. Whatever you do not complete in class today of the SmartBook questions is your homework tonight, and it will be, I will check it in later tonight or tomorrow, but please, please, please get those done. When you come back to class tomorrow, Friday, woohoo, Friday, we will do a data exercise and a reflection. And then if you have some other leftover stuff from the week, like the learn checks, you will get those done. And then we'll wrap up the week. We will start a new topic on Monday. So let's begin. This video is to help you understand what I want you to do today. So pause it when you need to, go do your work, and then come back to this video. So let's begin. So on the do now, you guys see that I said to please open up to page 34. So now I'm going to go to this guy. All right, page 34 is this guy right here, all about seafloor. So yesterday we made our models of seafloor spreading. And today, if you haven't done this already, some of you got this done already, you're going to read and annotate page 34. This is page 34. And I want you to watch the videos that I posted in McGraw-Hill Red Square through Hello ID. There is a brain pop and there's 2 animations, I think. Do the brain pop if you have time. I'm not grading the quiz, but it's a nice way to check your understanding. So spend a little time on those videos. They're all super short. And then you are going to go ahead and do evidence C. So right now, I want you to please pause the video, read and annotate this section, and then do evidence C. Then come back and we'll review evidence C together. All right, go. You're back, so that means you read and you annotated and watched the videos about seafloor spreading, this missing link for explaining continental drift. That's a really big idea for what we're learning this year. And now you're ready for evidence C. So evidence C says, what is the relationship between seafloor spreading and underwater mountains? So now we're going to go back to page 27. That's page 27. And let's review what you wrote. Now remember, what I wrote doesn't have to be exactly what you wrote, but the ideas should be very similar. So I wrote, new oceanic crust forms along the mid-ocean ridges and is destroyed at the trenches. So remember our models, new rock is constantly being formed at the mid-ocean ridge, and it's a conveyor belt, and it's getting pushed away. And then when that seafloor hits the land, the continental crust, it goes under, subducts, sub means under, and gets destroyed. But really, it's getting recycled, turns back into magma, and maybe it's going to come back in its next life as more seafloor. But remember, that was the important part of the model. So make sure that you have something to this effect for your evidence C. Seafloor spreading occurs at mid-ocean ridges. Very important. Okay, pause your video, write this down, and then we are going to turn to page 36. All right, you're back. So we are now going to move on to page 36. What is the theory of plate tectonics? So now welcome to the present. This is the contemporary accepted theory of how plates move or how continents move on our planet and continue to move. Is that in focus? I can't tell. Anywho, alrighty. So you're on this is page 36. And again, I'm going to ask you to please, in a moment, pause this video. I want you to read and annotate this text. And this 3-dimensional thinking, there's no writing that you need to do, but I want you to carefully look at this map. And then I want you to compare what this map shows to the very first map we looked at, this topographic map that shows elevation of features below the ocean's surface. Compare it to this isochron map that shows age of the rocks. Youngest rock is in the middle. It gets older as you go towards land, away from these mid-ocean ridges. And then go back to where you began. So take a moment, read, annotate. And when I say annotate, what I mean is circle the important words, underline important things, write question marks where you are confused or have a question, but interact with the text. These books are for you to write all over. Don't just leave them blank. Interact while you read. It makes you a better reader. Alrighty. Now, you can't draw on all your books, but you can draw on this book. So go ahead, pause the video, read these 2 paragraphs, annotate, and then compare the maps and think about what patterns do you notice between these 3 maps? And then when you're ready, come on back and we'll talk about it. Hopefully you're feeling excited about volcanoes and earthquakes, because that is where we are going next. But before we get to volcanoes and earthquakes, which will start next week, let's take a look at these maps. Let's talk about them real quick. So if you notice, these are these rigid slabs of land that we call plate tectonics, or there's these plates. And these plates are composed of oceanic crust and continental crust. And continental crust is on top of these plates, and they're moving. They're in constant motion, but as you read, very, very, very slowly. They move about 1 to 9 centimeters per year. So like this much to like this much per year. So that's why we don't really notice it. But as they moved over billions of years, we've gotten mountains and valleys and trenches and all kinds of great stuff. Okay, so we're putting together this incredible story about the surface of our planet and how it's changing. The maps, what I wanted you to begin noticing is, look at the boundaries of these plates, okay? The arrows show which way the plates are moving. Are they moving apart, like the mid-ocean ridge? Are they smashing together, like right along here? That's New Zealand. Or are they sliding past each other? And I don't know, did we show you that? No, we didn't get into that detail. We'll get there. Alrighty, so are they moving apart? Are they smashing together? Where is that happening? And then take a look at the isochron map. Okay, this right here, this mid-ocean ridge, where is that on our plate tectonic map? Let's take a look. It is, well, it's right here. Check it out. Who made that connection? The mid-ocean ridge is actually plate boundaries. Plate boundaries where the plates are moving apart. So you could put 1 foot on the North American plate and 1 foot on the Eurasian plate. You won't feel them moving apart though, because they move very slowly. All right, let's look over here. South America and Africa, okay? Remember, this is one big, huge, continuous mountain chain beneath the ocean, the mid-ocean ridge, the mid-Atlantic ridge, and that is all one big plate boundary between different plates. African plate, South American plate, North American plate, Eurasian plate. Now, if we go, let's go down to the Indian Ocean. Check it out. There's a big, huge mid-ocean ridge there too. How does that compare? It compares because it compares this way. That is also a plate boundary where the plates are, how are they moving? Apart. So think of the model. Think of these maps. And I hope that it's starting to come together and go, wow, for you. Alrighty, I think this stuff is awesome. All right, well, let's take a look at where the plates are smashing together. We have this plate right here, this smaller plate called the Nazca plate and the South America plate, and they appear to be smashing together. How does that affect age? Let's go take a look. So Nazca plate is here. This is the South American plate here, if you imagine that. And where they're smashing together, it's not the youngest rock, it's older than this rock over here. What is this rock over here? Oh, that's a plate boundary. Oh, it's pulling apart. So I want you to take a moment. If you didn't see this the first time, I want you to look at the plate boundaries. If the plates are pulling apart, how does that correlate to the age of the rock? And hopefully you're beginning to see where the plates are moving apart, the rock is really young. Where the plates are moving apart, the rock is really young, and we have mountains. Over here is the Mariana Trench. Mariana Trench, plates are moving together. Where the plates are moving together, we have trenches. What about age of the rocks? Mariana Trench is going to be over here. It's kind of hard to see there. We have some red, we have some green, it's a little bit of everything. Not real clear, but it's not completely all red. Over, let's see here. Where would be another good example? Let's go down here. Let's go down here. There's this little weird redness here and greenness. What is going on down there? There's a tiny little plate. It's called the Scotia Plate. What's happening? Smashing together. All right. Now, the big thing that I want you to take away is this. Where the plates are pulling apart, we're seeing mid-ocean ridges, and the rock is the youngest. Where the plates are smashing together, sometimes we're seeing trenches, and it's not always the youngest rock. Because at this point in time, we now know the youngest rock is formed at the mid-ocean ridges. Awesome. Seafloor spreading. Alrighty, so enough there. Let's go ahead and, if you haven't already, please, please, please go ahead and complete evidence D on page 27. Work on it for a couple minutes and then come back and we'll review what you put. Okay, you're back. You took some time to think about evidence D and wrote something down on your paper. Let's talk about it. Again, you do not have these exact words. It's okay. Just make sure you have the main idea. So what evidence have you collected to explain how this feature is evidence that the continents move? So we're still talking about the feature, the feature, the feature. We're talking about the mid-ocean ridge. So mid-ocean ridges are evidence that continents move because it's where new seafloor is formed and then it spreads apart. And that's what we are seeing between all three maps now, some of our investigations, and the model that we made this week. So the continents move as the seafloor spreads apart. That is the important concept for the week, for reals. Okay, so I'm hoping you're feeling pretty good about this. Now, pause the video, and I would like you to please, what are we doing next? I don't remember. Hold on. This is what we're doing. I want you guys to take a moment, and I would like you to revise your claim, and then write your reasoning, pause the video, and then we will compare answers. Okay. So remember, in science, the way we do things is we come up with a claim and then we collect evidence, and that evidence may change our thinking or we may add to our thinking. So now that's what the revised claim is. We didn't go over this in the first lesson, but I would like you guys to take a look at what I wrote. You can change yours, add to it, etc. So we started last week talking about what's on the bottom of the ocean, and we discovered there's a huge mountain chain, this big, huge, continuous one. Great. And a lot of you told me, and you drew it on your boards, that this mountain range exists, the mid-ocean ridge, because the plates are smashing together. That's a very good idea, and that is one way that mountains are made. But this mid-ocean ridge is not made that way. So the ocean floor has a huge mountain range called a mid-ocean ridge, where the seafloor spreads apart, causing new oceanic crust to form and move away in opposite directions. That's a lot of information. And this is where we are at this point. So at the very, very least, I hope that at this point in time, you understand that that big, huge mid-ocean ridge exists. because that is where the seafloor is spreading apart. Magma is coming up from within the earth, cooling, forming new rock, these mountains, and this amazing feature that we see in many places in the middle of our oceans, because that's where new seafloor is forming. And as the new seafloor forms, it's pushing away, 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 like a conveyor belt, which essentially is also pushing the continents around our planet. It's been doing that for billions of years. So that's a revised claim. Our reasoning, pause the video whenever you need to. The reasoning is pulling together all of the evidence and backing it up with scientific explanation. So this is a lot. Compare what you have, add what you need to. But what I put was, the evidence I collected supports my claim because the seafloor spreads apart and lava erupts there, causing this mid-ocean ridge to form. On page 34, this is where I got some of my information. So when you are writing these things, you can go back and look up information. Magma is less dense than surrounding rock. There's some of my scientific explanation. I got that from the text. It rises up, it cools, and forms new rock. The two halves of the oceanic crust spread apart in opposite directions like a conveyor belt. This is what moves continents, which equals seafloor spreading. Okay, there's a lot of information there, and after you're done writing this, you can maybe take a brain break, turn to your neighbor, and just read your answers or talk it out. Okay, a lot of information here. You are now ready to pause this video and go do your SmartBook questions, and if you have time, your Learn checks. So I will take you there to remind you where we're going. So go ahead, pause the video, take a brain break, talk to your neighbor about what you wrote, and then we're going to do some review questions. All right, so I'm clicking on the red square through Hello ID to get to my review questions, my SmartBook questions, and it's very slow, but here we go. Okay, so remember, pick Worthing Way Middle School, and yours will look a little different than mine. All right. In the dashboard. So by the way, does anybody know where this dashboard is, this picture is from, or what you're looking at? It's very apropos for what we're studying right now. If you said Iceland, you are correct. And this is actually the rift zone where the North American plate and the Eurasian plate are coming apart. So that is what you're looking at in that picture, and you can, that's the only place that you can actually walk along the mid-ocean ridge, is in the country of Iceland. We'll talk about it again as we get into our next lesson. Alrighty, so here you have 3 videos that I do want you to watch. Ooh, looks like there's a repeat. I'll clean that up. Actually, there's 2 repeats. So you have some videos here, 2 or 3, depending on which class you are. Watch those if you haven't already, but what I really want you to look at is this right here, SmartBook, lesson 1 and 2. This is what I would like you to do next. If you finish this SmartBook questions today, then move on to the lesson check. They are not time limits, or they're not on a time limit. If you don't finish the SmartBook today, then please do that on your own time and have it done before you come to class tomorrow. So, SmartBook questions, lessons 1 and 2, that is what you are doing for the remaining time in class. And if you have time, work on your learning checks, which will be due by the end of class tomorrow. All right, that is all I have for you. Do your very, very best. And hopefully, if you have any questions, well, if you have questions, your guest teacher can answer them for you today. You guys may also email me or send me a message through Schoology, and I will get back to you as soon as I can. So I hope this video was helpful. I know you have a lot of work to get done today, but we're wrapping up the week, And tomorrow we'll do a Data Friday, answer any questions that you have, and then Monday we start a new lesson. So treat the learning checks as quizzes. They will count as quiz grades. Use the Smart Book, which now finally came up, as review. It is review from last week, learning, and review for this week. So that's why it's a little bit longer. All right, do your best, and thank you for listening.